Hello, hi, welcome to Apsana classes. Today in this video, let's learn about the demultiplexers or demarks. So before that, a beautiful quote sent by Ashok sir. Take up one idea, make that one idea your life. Think of it, dream of it, live on that idea. Let the brain, muscle and every nerve of your body, every part of your body be full of that idea and just leave every ideas alone. This is the only way to get success, isn't it? Yes. So today's topic is demultiplexer. So demultiplexer is a combinational logic circuit. As it is a combinational logic circuit, so the output of that demux depends upon our present inputs that we are giving. So what are the inputs? So we have three inputs for the demultiplexer. In the multiplexer, we have only two inputs, those are selection lines. But here, along with the selection lines, we also have another line, that is a constant data line. See, you have a constant data line. So basically, demultiplexer, demux or demux is nothing but one to many. One to many. The basic logic is one to many. From one line, from one data line, it should be sent to the desired Y0, Y1 or Y2 or Y3 line. I would like to send data that I have here, but I would like to send this data to particular channel. So I have here Y0, Y1, Y2, Y3. Then how you will select that particular one? By selection line S1 and S0. So from here you can say that you have 1, 2 and 3 inputs to demultiplexer and you will get one output, that is one output you will get either at Y0, Y2, Y3 or Y1. So see, one to many. So one data is going to many output lines based upon our selection lines. Okay, one data is sent to many output lines based upon our selection lines. Okay, fine. Then here we have a question. So how that particular data is sent? We know by selection line. Then how? It is depends upon 2 power n. If I have 2 power n as output lines, then n selection lines you will have. Okay. Then let's look at its truth table. So truth table is nothing but the relation between the inputs and outputs. So what are the inputs we have here? D, that is our data line, and the selection lines S0 and S1. Then what are the output lines we have? 4 we have here, as we are going to take for 4 cross 1 demux. Okay. Truth table, the relation between inputs and outputs. So what are the inputs? That is D, fine. The selection lines S1 and S0 input. For outputs we have 4 we have. So 4 we have. So what are those? Y3, Y2, Y1 and Y0. Okay, in order to get data at Y0 line, I have to make S1 and S0 as 0, 0. Then you will get the data at Y0. Then what about at the lines y3, y2 and y1? Here we don't get any data, so we make as 0. If I would like to get data at y1, then 0, 1 and 1, 0 and 1, 1 for the respective y3, y2, y1 lines. So data at here, everyone 0. So data at here 0, 0. In here I'll get the data at this position. So making every line as 0, 0. This is a truth table. Then how we will get the equation for each? So for each y naught, for output of y naught, you will get the equation of d into s1 bar and s0 bar. As you have 0, 0, if you multiply with the 0, you will get the output as 0. But in order to get the information d, we make it as 1 in the implementation only. Only at the implementation. Okay. Don't think that I am taking directly 1, 1. If I take directly 1, 1, I will get the information at the y3. For at the implementation, you will come to know how it is going on. So D at which positions? S1, S0. As we have zeros, we consider in inverters. So you will get the information D at y0. So same as at y1, information will be S1 bar S0. Information D. At y2, your information D, and here we have 0 and S0. So S1 into S0 bar equal to D, the information. So in order to get the information at the y3, you have to make S1 and S0 as 1, 1. So already they are in 1, so you need not to put any bars. So y3. D, S1, S0 equal to D. Let's look at its logic diagram, how it is going to be. As we have four outputs, we will get them at AND gates. Y0, Y1, Y2 and Y3. But the inputs, so selection line S1, S0, and we have bars consideration in order to get outputs. So we also take inverters and a continuous constant data line D. So that is the data line that should be given to every AND gate in order to get the output D at respective Y0, Y2, Y3, Y1 at selected S1 and S0 lines. So to get the data at Y0, you have to make S1, S2 as 0, 0. But how you will implement here? Here you implement with bars. So inverters you have to take. Okay. And then here I'll tell you the implementation also, example 1, then you will get a clear note why we are giving to inverters and all. Okay. So S1 bar, so S1, S0 as it is. And here S1 and S0 bar, S0 bar. And here no inverters, no need to get it inverters, go to inverters. Okay, I made selection lines as 0, 0, 0, 0. Then I would like to get data only at the Y0. See, here I made it as 0. So inverter of S0 will get 1. So 1 into D is D, but here have another 1. because S naught is 0 but inverted we have given to inverter, then we get 1. So D into 1 into 1 we will get data D. So C. So S1, S0, 0, 0 we have given. Then I should get 0, 0, 0 at these lines. We should not get any data. Let's see, is it getting or not? So here we have 1. So 1 into D data. But here we have connected S0 to, AND gate to S0. So at S0 we have 0. So 0 into something will get 0. So same as, see, 0. Here we have 1. D. So D into 0 into 1, 0. Here it is given to 0. So 0. D. So D into 0 into 0, 0. We get or not? We get data at only Y naught as we are given the selection lines as 0, 0. So 0, 0 selection lines, data at Y naught. Satisfied. The same as 0, 1, 1, 0.